Welcome, everyone, to another episode where we explore geodesy and influential geodesists in the world. My name is Mehdi Ishaq, and today we are honored to have with us Professor Cheinway Hwang, a leading geodesist from the National Yang Ming Tung University of Taiwan. Professor Hwang has built a remarkable career through his research and expertise in geodesy, satellite altimetry, satellite gravimetry, and oceanography. Please join us as we explore his career, insights, and how his work has affected our knowledge in the field. Welcome, Professor Hwang, and thank you very much for accepting my invitation to this interview.
Yeah, thank you for inviting me. I'm honored to be interviewed by you. Yeah.
My pleasure. My pleasure. So, Hwang, Professor Hwang, I have read your articles for years, so I know you over 20 years, maybe, from your articles. So I think it would be very interesting that you explain or tell us a little bit more about the journey that you have had and what has kept you interested in this subject during these years.
Okay. Well, I actually did my bachelor in civil engineering in Chenkong University, Taiwan, and then I did my master degree and PhD at the Ohio State. Well, actually, if someone does gets bachelor degree, actually, the age is young, right? You have no particular interest, and especially in Taiwan, well, we have very competitive environment for entering good university, and NCKU is definitely one of the best university in Taiwan. So after I finished my bachelor, I thought I should have gone to the US for some study, okay? And then I still remember I read the book, Physical Geodesy, which was actually taught in my undergraduate program. And then I wrote a letter to Richard Webb, Dick Webb, whether he can accept me as his master student. And actually, he accepted me, okay? So I did my master in the beginning with Dick Webb, and then all this physical geodesy, and wrote a thesis about satellite altimetry, marine gravity. I use his computer program, Chinese program, postboard program for my master work. And then I was asked to develop a theory on orthogonal function in the ocean. And I think that was a big project, 3-year project. And then I took my math class and some other classes for that PhD thesis. And somehow I finished that. It's quite theoretical, my PhD. So from master to PhD, I learned mostly physical geodesy, satellite geodesy. And I think my most important mentor is Dick Webb, okay? The geoid guy, he had this OCU model, yeah, from very beginning to his retirement, okay? And later his student, Nicholas Pavlis, developed this EGM08, and it's still very useful today. Adjustment theory from Erhol, Watara, Burkhardt, Shefflin. I learned GPS from Krykov. I learned satellite geodesy from Mueller. Unfortunately, most of these mentors have passed away, okay? I don't know whether Krykov is still okay, doing okay, but I know from Dick Webb, Ivan Mueller to Watara, they passed away. Professor Shefflin, I live in OSU. So this is my journey to geodesy.
Tell me, what kept you interested in the subject? Is it something special?
No, I think after my PhD, I went to Oxford University, UK, for my postdoc. That was, very pleasant who was my supervisor in Oxford. He was a friend of Dick Webb. I think he was an associate professor in MIT, and he returned to England because he is from Britain. So I think when I was doing postdoc there, people in different fields asked me about physical geodesy. You know, the Earth Science Department was a merger of Department of Geodesy and Geological Science. So still there was a very active reader, our lecturer. I kind of forgot his name. I think Barry Parson is also my key mentor, especially when I was in Oxford. Okay, I co-authored like 5 papers with him, and he showed me how to write papers, how to be successful author. Okay, so he after my PhD, he was very influential in my career. So I kept motivated in this field. Okay.
Okay,
Yeah.
so that's okay. That's interesting. So interesting. Yeah. Cheinway, you have done a lot during years for geodesy. What type of changes have you observed in the geodesy so far during years?
I can. I think. Of course, you know you have new missions, right? Like even in satellite altimeter, you have very simple, low accuracy geoset. I mean, well, geoset wouldn't be a low accuracy. The volume of data is not that much. And later you have all this geodetic mission. And now you have a SWAT altimeter. That's like INSA altimeter. It provides data over a swath.
Yeah.
So in fact, we face a large volume of data, and you just need a new method to process them. And also, I can see that we know this subject of climate change, environment change, and mapping used to be in a, I mean, the understanding of mapping is static. I mean, like coordinate of your control point won't change, but actually they will change. And you have to deal with this. And in fact, in the case of Taiwan and many countries in the world, you have to monitor coordinate change. So now you can no longer have a static control network. You have to understand the velocity field of your network. So if I would say, and then later you have grace data, and in my personal experience, I keep doing satellite altimetry. I also learn airborne gravity. This is something done by people like Rene Forsberg, okay? But somehow because the need of geoid model in Taiwan, and our government provides funding for this. So I start to learn new techniques like airborne, shipborne, superconducting, absolute gravity. But these are all physical geodesy. So I can see that we have more data, more different sensors. You encounter a sensor that might not be something you're familiar with when you did your degree, you know. So you constantly face new kind of data in volume, in processing technique. This is what I feel. And everything's time variable. I mean, time, you know, it's not like, well, I'm not talking about like grace. We are talking about actually even the coordinate of your control point are changing. You cannot be blind to these change. You have to deal with them. Okay. And this is my feeling.
Thank you very much. You know, still I feel that this subject with that those applications that we know is not still known to the public on people. And when I talk to people, I say that I am geodesist, they immediately say geophysicist or geologist. It still is not known for. How can we explain the society who is like that? The importance of geodesy.
I think the exceptional law of geodesy is precision. For example, in the previous subject, you need to, for example, if you want to understand a centimeter or millimeter change somewhere, I mean, experiencing then subsidence, you cannot use the knowledge in geology or some general earth science to process such data. And today, geo is still a very active, important subject. So you cannot do heighting or elevation without a geoid model. So something like geoid model or lens subsidence modeling, especially at millimeter level accuracy. These are for daily life, at least in Taiwan. For example, our geo model, developed by me, are used in our official mapping agency. They are used everywhere. They are used for real-time determination of oceanography height. And maybe in the message is hidden somewhere, but if I explain to a user, I would say, okay, you cannot just have like geometric sensor to do elevation. You need geo model. Okay, if you want to monitor lens subsidence at millimeter level, you cannot just use navigational GPS receiver to determine coordinate change. No, you cannot do this. You have to have a precise background of doing this thing. And this is the job of geodesy. So I think there are many examples you can list for daily, everyday life importance. But so, like I said, these are the experts in this field are mostly in civil engineering in Taiwan. Okay, not even in earth sciences. Earth scientists they need millimeter positioning from geodesists. So, for example, we just have a big earthquake. Okay, so a few days later, our mapping agency published this location. The location field. The change near the epicenter, and this is something. No, and then this kind of event, despite this is a tragic event, but people understand that you need geodesy to determine displacement like this, at least at this level, okay, of accuracy. So they are actually in everyday life. I think it's everywhere. But of course, people who do this, they are not a large volume of people doing this, but definitely you need people like us doing this, okay.
Thank you very much for that. Thank you. Well, sometimes I make an example for the ordinary people. I say that you have mobile phone and you have maps and navigator. This is the simplest, more visible application of geodesy. You can just simply open your mobile and see it there. That can be done.
But if we use this example, like mobile phone positioning to find a gas station, convenient shop, a coffee shop like this. I think these examples do not emphasize the importance of geodesy, but I think this could be example, but they will argue that okay, this is not geodesy. This is developed by someone in communication, okay, in information process, something like this. So maybe we can explain more, okay? But indeed, this is one example. I mean, mobile phone positioning, locating gas station, and all this.
Well, actually, it's not precise. We know that this is not a precise. As we in geodesy
Sure.
always look talking about precision and accuracy, and it is not that. It's just very, very, very simple and rough, actually, example for geodesy. So, but thank you very much. What do you see in the future, the trend of geodesy in 10, 20 years from now? To which direction are we going? What will happen?
I think whatever we are doing will be valid for another 20 years or many decades to go. Like precise positioning. Every country need geodesists in this field. Like they know how to perform adjustment. They know how to build a geoid model.
Yeah.
They know how to build a geodetic network and monitor the change of the network. This is definitely for last another 100 years. Okay, it won't change. You may see less people or spread of people into different fields. But definitely every country, every region needs specialty like this. I can even predict that the number of people will increase. It just, like I said in the beginning, that they may be hidden, I use the word. They are hidden somewhere in, like typically like civil engineering, maybe earth sciences, but I have some opinion about earth sciences. Okay. People regard geodesy as a branch of earth sciences. I think it could be it could be wrong conception. Okay. So if you are going to Earth, if you serious, you are an earth scientist, you think you are studying earthquake geology or something like this. Indeed, earthquake need geodesy to measure precise conic change, seismic change. But only if you have the support of geodesists like us.
What is your advice to us and the next, those people younger than me, for the next generation about geodesy?
If from my example, I would say that if you are a geodesist, you have to be aware of the new data. You have to use your publication to convince your fund supporter to raise fund for your research, and this in turn promote geodesy. And also participate in organizations such as the IAG, and use the knowledge learned from other geodesists to promote new subjects. And so in my single most important advice, if it is okay, will be continuously engage and publish in the field of geodesy, and publish papers only that are unique to geodesy, not something like people in earth science can do. Okay. Although I work with earth scientists, but we tend to be a side discipline. I mean, it's not, but we have our own contribution, publication to encourage funding and promote geodesy.
Wonderful, wonderful. Thank you. And as a last question, maybe, what can we do so that the policymakers and those are involved in the running the government and society can see geodesy more? Is it publications are just enough for that, or any advice?
Yeah. Again, I would say because if you are a geodesist, if you are a government official, that's a different story. Okay, because imagine you are a civil servant for some mapping agency. You cannot actually do much about it, about geodesy. You are a service and someone make decision. But if you are people in academic like me, you can you can let policymakers look at this. For example, you point out is that every nation, every country, every region is developing precision centimeter geoid model, and this need many resources from gravity measurement to processing technique to collecting GNS library data for validation. And this is the most important piece of infrastructure in mapping service. Every country is doing this. So you need to continue to invest resources into this and to invest scientists, geologists for this. I think, and also this global change, environment change, you need someone who understands precision to perform these kind of tests. It's not something can be done by scientists in earth science, by geologists. Okay.
Yeah. I agree. So thank you very much, Cheinwei, for this interview. I really enjoyed talking to you. You share your experiences. I'm very thankful for that.
Okay, thank you.
Thank you.
So
Bye bye.